Anybody not here for M1800? Perfect. Has anybody ever done that? Gone to the wrong classroom, sat down, had the class start? What class did you go to? What class were you supposed to be in? 1310? Isn't that in a computer classroom? Oh, there's a lecture part that's not in the classroom? Okay. Yeah, so I actually did that one term. I thought I was teaching in Washburn 229. About 10, 15 minutes before the class was supposed to start, I went to Washburn 229, first day of school, first day of classes that term. And there was some guy still teaching his class in there. I was like, that's rude, but I guess I am a little bit early. So there's a little table by the door there. I don't know if you've been to that room, but there's like a little hallway that it goes into the lecture hall. So I left my stuff on the little table and I went out and I got a drink of water, watching my watch. Finally, I go back in, and he's like mid-lecture. He's just going along. And it turns out he had a 2-hour lecture, and I was there in the middle of it. And I was teaching in Salisbury Labs. So I was late for that first day that one time. It's kind of not cool for the professor to be late on the first day, right? If you don't know this, I am not Professor Brown. I am Professor Bergstrom. Professor Brown is in a meeting in St. Louis right now. Actually, I was on a conference call to that meeting until about 15 minutes ago when I decided to walk over here. He will do pretty much all of the rest of the lectures. You'll see me this time in lecture. Maybe if he gets sick or has some other trip and I cover for him for a lecture. But you'll see me in the labs. So I'm responsible this term for the lab portion of the class. Actually, I'm responsible every term for the lab portion of the class. Professor Brown is responsible this term for the lecture portion of the class. He'll deal with things like lecture quizzes and grading and all of that stuff. I get to do the fun part this year. This term. We alternate terms on being in charge of the lecture part. I'd like everybody to get one of these index cards. I believe there's enough. I'm going to start here, and if it gets to the end, pass it up to the next row and pass it back down this way. And then if somebody at the end, I'll start here. And I'll just give you the rest of them. We'll see if everybody gets one. If not, get a scrap of paper or something to write on. Okay, so while those index cards are going around, take care of just a little bit more housekeeping stuff for the class. Who had the lab this morning? How many? Be proud, hands high. 1, 2, 3, 4, 5, 6, 7. That was my fault. I totally made an announcement that said there was not going to be any labs this week. It is on the Canvas site, but I never made the Canvas site available to you guys. That is totally on me. I did it yesterday to make sure that people at least had a chance to know that we're not going to start labs until next Monday. So if you're in section 1, raise your hand if you're in section 1. Raise your hand if you have no idea which section you're in. Okay. If your schedule says you have labs on Mondays from 3 to 5, you're in section 1. If you're in section 1, you will have lab on Monday and Wednesday next week. If you're in any of the other sections, you won't. You'll have lab on Tuesday and Thursday. So labs will start on Monday, but only for the people in section 1. Start on Tuesday for everybody else. Okay, that makes sense? We have 4 lab sections. One of them meets on Wednesdays and Mondays. The other one meets on Thursdays and Tuesdays. See how I did that backwards? Okay, everybody get a card? Who doesn't have a card? Guys, pass the cards faster. Come on. Somebody get this guy a card. If not, get a piece of paper. You know what I'm supposed to do? I'm supposed to save a card for me to write on it what you guys were going to write and then use the document camera. Oh well, I'll use the board. On the card, when you get the card, answer the 3 questions. Number the sides 1 and 2 on the card. Can you do that? You don't have to do that first. I'm just saying before you give them back to me, do that. On side 1, say, why are, actually don't write why are you here. Answer the question, why are you here? Okay? Answer the question, why are you here? If you have a little extra time, you can answer the question, why am I here. And it really doesn't matter which order you should indicate which order they're in. So the first one, I mean, why are you here? And the second one, I mean, why am I here? But as long as you write complete sentences, I should be able to figure out which answer is which. Okay? You do not need your name. These are anonymous. I always want to say unanimous, but they're probably anonymous, not unanimous. Why are you here? Why do you think I am here? On side 2 of the card. You could be working on side 1 while I'm writing here. What is the difference between making, make ing, and manufacturing? So difference between making and I paraphrased side 1 there. And I abbreviated manufacturing in question 2. Should be the same questions on both sides. I just got lazy. All right. So take just a moment here. Why are you here? Why am I here? What's the difference between making and manufacturing on the other side? So the why questions go on one side. The difference question goes on the other side. Okay. Let's see. Have we got the time? What time is it? You ever notice how they design classrooms so that you guys know how much longer it's going to be? And I could talk forever because I don't know when to stop. You notice that? Anybody ever watch videos on the computer? Like YouTube videos, stuff like that? Any of you? You should take the class when I teach it. When I teach it, I give assigned homework reading assignments. But half the time they are watch this YouTube video. I'm pretty sure Professor Brown mostly gives reading assignments where you have to read something. Oh well. Now you get to watch videos too, because there's a bunch of videos associated with the labs. So, anybody need more time? Raise your hand if you need more time. Okay, we'll go another 2 minutes. Anybody know a good song to sing? Fill the time? No. Songs about manufacturing. Can you see okay? Okay. Or you just want to be able to hide down there and go to sleep? Who's here with an add drop slip wants to get signed into the class? Anybody? Somebody? You have one. Just one? Okay. I'll tell everybody in case your friends have an add drop slip and they want to get in the class. I don't sign add drop slips. It's up to the registrar whether or not you get into the class because of the size of the room. So if I sign an add drop slip and we're over the capacity for the room, they won't process it anyway. We have a little bit of flexibility with labs and lab sections, but on the 3rd day of the term, so that'll be Wednesday this week, sometime in the afternoon of the 3rd day of the term, they open up any classes that are not completely full. And you can just register online the normal way. If that doesn't work, come see me and we'll see if we can get you in the class through the as long as this classroom has enough chairs. And so if everybody showed up for the first day, raise your hand if you're not here. If everybody showed up today and there seems to be enough chairs, they'll probably let you in the class, no problem. But last year we they started enforcing the fire code last year. They used to let me sign more people into the class than could fit in the classroom, with the understanding that most people will, most of the class sessions will have a few people that miss the class, so it works out. I don't know, maybe the fire marshal found out, but they've started counting the number of chairs and making sure that we comply with that now. So we can't have exceptions. Is that everybody ready? All right. Pass the cards so that he ends up with them. When you get the cards, give them to me. Okay. All right. So now that you've had a chance to talk about the difference between making and manufacturing, let's talk about it as a group. Who's been to the cool new makerspace at WPI? Who hasn't? Really? Haven't even walked through the building? Haven't bought a pretzel?
I live in the building, but I've never been to.
She lives upstairs. They spent $49 million to build your bedroom, and you didn't even go downstairs and get a pretzel yet? See, you've been in the building then. I win. All right. But no, there's a lot of talk in the media. There's a lot of talk all over about making and makerspaces and the fact that making is becoming a big thing. There's giant makerspace in Boston on the waterfront down there. Autodesk built this giant makerspace. You can go in there. They get robots and machine tools and stuff like that. There's another big one. Actually, Autodesk has another big one in San Francisco and another big one in New York City. And then there's smaller makerspaces around, right? Is anybody a member of a makerspace? Anybody ever made something in a makerspace? Where's your makerspace? Portland, Maine. What'd you make there?
I built the makerspace.
You built the makerspace. He made the makerspace. Okay, cool. Thank you. All right. What does it mean to make in a makerspace? I actually like to say WPI is very proud of the new $50 million building. And we should be proud when we get a new $50 million building. But the building itself is not the makerspace. You guys know that, right? WPI is the makerspace. That building is the focal point of the makerspace. Because people don't just make stuff here, they make stuff all over the whole campus. Okay, I'm off my soapbox. What does it mean to make? Yeah, up in the back. To create something. So when we're making, anybody get a stack of paper? I'm going to use the document camera here, I think. But I didn't bring any paper. Maybe you get some paper I can borrow? Your whole notebook. I normally bring paper for that. Thank you very much. What's your name? Oh, he's the one that wants to get signed into the class. Let's go. Turn on document camera. Oh, this is cool paper. It's got little dots on it. Or am I seeing things? What are the dots for? Where do you get this stuff? What a good idea. It's expensive to print if you do it at the library. You guys, it's still 10 cents a page there? It's 10 cents a page there when I was a student here to make photocopies. So at least inflation hasn't got them. But you do know that if you come into the manufacturing labs just across the little alleyway there, and you find a piece of scrap aluminum or something, you could put it in the CNC machine and you could engrave that for no charge. Just saying. Now, if you want a specific piece of material, you might have to buy it. And it would cost more than 10 cents. But, all right, so what was the question? What is making, right? And you said to create. To create what? Does anybody argue that making is not to create? Okay, nobody argues with you, so they're all very shy. How do you tell the extroverted engineer? That's not true. I'm an engineer. I'm pretty extroverted. How do you tell the extroverted engineer? They look at your shoes when they talk to you. All right, we're creating something. You guys got to get more into this. I want my lecture to be dynamic. You guys got to get into this. We're creating something. What beyond create, so I just created a thought. Did I make anything? No, so you got more than create. Create is included, yeah. Create maybe a physical thing. I could make you angry. Huh. But in a sense that we're talking about here with maker spaces and things like that, we mean to create something physical, right? Can you guys see what I'm writing? I always wonder why nobody says anything when that happens. Maybe it's a plan, right? Maybe I meant to have it off and then show it to you. Create something physical. Right? We've all made something, right? Intuitively, we have this understanding of what making is because we all made something. My daughter made brownies this weekend, right? So we make stuff. Okay. Who's read the course description for this class? Hands up high. Who's read the course description for this class? Red hair over here. You didn't raise your hand. Why'd you take the class? No way. This class is not a requirement for any major. It fulfills requirements for several majors, but there's ways to get around it. So why'd you choose this way to fulfill that requirement? Who wants to make things? Army. I knew it was ROTC, but Navy. See, it's got a Y at the end. I had a 50-50 shot there. No, I had a 2/3 chance, 1/3. I don't know. Go for it. Navy. What do you got? See, was to fulfill requirements and talking to people. You learned that when Professor Brown teaches the class, is the time to take it? Perfect. Hard Rock Cafe. Did you raise your hand? Did you read it yet?
I did. I don't remember.
But all right, but you read it at least. Before you decided to take the class or after?
After.
Okay. Why'd you take the class?
I wanted to get
Machining experience. Machining experience and realization. Yeah, another word we could use here besides create is we could say realize, right? We need to realize the thing that we wanted to make. And that's the requirement that most of you are fulfilling with taking this class, right? Is your realization requirement because this fulfills that. Some people. What's your major? Red hair. What's your name? Matt. I'll start calling you Matt instead of red hair then. What's that? IMGD art major. So this is your out of major engineering credit then. Yeah. So you totally had lots of options. You could have taken double E for dummies. You probably could have taken 1310. So this is redundant. Yeah, sweet. I love to be redundant. You said machining, right? Who said machining? You said machining. What do you want to machine? Why do you want to machine? You want a machine to make stuff, right? What's the most used word in the course description? Anybody know? Anybody do a word count in the course description? Uniquely identify words and see how many times they were used? What's that? Pretty sure it's manufacturing. Certainly, I hate it. When I do that, it's supposed to automatically switch. Okay. Back. PC. I teach in several classrooms on campus, and no two of them have the same control system for the media center. There might be two of them. So there might be two or I or an, but the most repeated important word is manufacturing. We've been talking about making, right? What's the difference between making and manufacturing? You get an idea? Who thinks they've got the definition for the difference, or the difference? Like the difference. Who's got the difference? Okay, hold your thought. Did you write it down?
Yeah.
Is it on the card? Is yours on the card? Okay, hold your thought. For those of you that haven't read the course description, this course is about manufacturing. It's about manufacturing. Wait a minute, it's about manufacturing and manufacturing science and engineering. Oh shit, what's the difference between science and engineering? Yes. Science is the study of stuff. The world, the natural world. I suppose the supernatural world could be included if we had figured out a way to study it, right? We shouldn't be limiting ourselves to natural things. What's engineering then? Yeah. Taking whatever the scientists discover and building stuff with it. I see. I think it's beyond that. In fact, you cannot be a good engineer unless you have first become a good scientist, I would argue. So I like to look at it as scientists like to ask the question why, right? Would you agree? Scientists like to ask the question why. Why is this table flat? Why does the pen start to slide at a certain angle? Anybody know why? Friction coefficient, right? So scientists like to ask the question why. Engineers like to ask the question, why not? Can we go to the moon? Why not? Right? So difference between science and engineering. But to be a good engineer, you got to understand some of the science. You have to actually understand why not sometimes and why it's going to be impossible. Although, I guess the best inventor is the person who finds out what everybody believes is impossible and then goes and solves it. Right? Okay. So science and engineering, science of manufacturing. We're also going to talk about CNC machining, right? And somebody mentioned machining. We're going to do CNC machining. We are not going to do Etch-a-Sketch style machining. If anybody's here because they want to learn how to do Etch-a-Sketch style machining, this is the wrong class. I think, yeah, I don't know if there's any place around here where you can learn that. By turning the handles. Yeah, I call it Etch-a-Sketch style machining. Okay. All right, so what is manufacturing now? You guys had differences, right? I remember that. But let's talk about what is manufacturing. We talked about what is making. What is manufacturing? Somebody's got to talk. I forget I didn't ask your name. What's your name? Daniel, Matt, and girl who doesn't go to the makerspace. Daniel. Mass producing. This time I'm going to remember to switch. All right. So you've introduced 3 new words. What, you guys all know what he means, right? Anybody who doesn't know what he means? WPI hat. What's your name? Sophia. What is mass? It's not how heavy I am, right? What's mass here? A large quantity. I believed you that you knew what he meant. Lots. You know what I want to have is like an app that just says the name of a student that's supposed to be in the class. And then I just say, Billy. And if Billy's not in the class, well, then I guess Billy won't be embarrassed. But everybody else would know that Billy got called on and he wasn't in the class, right? What's your name here? Red sweatshirt?
Carmen.
Carmen. Sophia, Carmen. Girl that doesn't go in the makerspace. Daniel, Matt. Carmen. Go. Oh, produce. What did he mean when he said produce?
Make.
To make. And what did he mean when he meant something?
Product.
Carmen says product. Anybody else get an idea what he said? Tall guy, white shirt. You may not be tall standing up, but you're tall sitting down. You have a long torso. I have a long torso. I have short legs. An object. Not to object, but an object. The hairband. What's your name? Ine. Ine. What did he mean when he said something? An idea. When I was an undergraduate student here, there was an office that had all of the manufacturing graduate students. So we were all grouped together in one office. They actually opened the door once a day and threw food in. Now, it was not quite that bad, although it's twice a day. This one office had all these manufacturing graduate students were in the same office. And so you'd go there to visit your TA or something when you're in a manufacturing class. And they had on the door of the office, it said, thesis fabrication area. So to finish your graduate program, you have to write a thesis. Fabricate, you guys got it. The pun was totally intended. Mass produce something. Lots make product, object, idea. What's it take to produce something? Yeah, guy next to Matt. It takes raw materials. So we'd have raw materials. And they go in. What do we need after raw materials? Yes. We need a process that acts on them. Out of the process comes what? A product, an object, an idea, the thing we wanted to make, right? Hopefully. And if we're doing, you said two words, you didn't just say process. You said repeatable process. And if we're doing mass production, then a repeatable process is very good for us to have. If we only need one part, is the difference between making and manufacturing how many parts you need? He's thinking maybe. Is it the process that you do it? What could the differences be? It could be the number of parts, the process. So number of parts. You said the complexity of the process? The process. You said based on a well-designed model, maybe? I'm trying to write it in a few words. That's what you meant, though? So make something from a model. Yes. The desired quality or the outcome of the quality? Okay. The quality of the part, yeah. Efficiency. I'm going to have efficiency of spelling and just not care if I spell it right. Yes. Repeatability. Yeah. Cost effective, that's what you meant when you said efficiency, right? Who said efficiency? Somebody over here? Did you mean cost effectiveness? All right, I'll list it as a separate thing. Are these different? So if you're moving from making to manufacturing, are these things necessarily different between them? So making will have one thing and manufacturing will have another requirement? Is that what we're trying to say here? Yeah?
More of like prototyping, figure ideas, very physical concept.
You're the one that said commercial viability, right? What's your name? Cam. You'll fit right in this class. Half the class is about CAM. You guys know what CAM is? Besides the guy in the back row with the hat. Computer-aided manufacturing or computer-aided machining. And you guys will, through the course of this class, learn how to use CAM software to write the programs that run on the machine tools that make the parts. This class, I said it was about manufacturing, right? We will not do any manufacturing in this class. We will do plenty of making in this class. Actually, is that true? There is a product that we manufacture in this class. And that's the key thing. You said commercial viability, right? Back over here, we said produce a product. The only difference between making and manufacturing is that when you're manufacturing, there is a customer to buy the thing that you made. That's the difference between making and manufacturing. You can use all of the same processes. You'll do the same steps. I have a good friend. He used to be a manufacturer. He's retired. He recently used his CNC machine in his shed in his backyard to make a watch. Certainly takes high precision, high repeatability to be able to make the components that go in a watch. However, he was making it for himself. He was making it, he wasn't manufacturing it. When we manufacture it, there is a customer. Manufacturers do manufacturing, makers do making, and there's certainly overlap. When you're at the prototyping step, if the customer is not paying for it, are you making it or are you manufacturing it? A lot of times if you're a manufacturing company, so one of the small types of manufacturing companies that we'll see a lot of are, they call them job shops. So someone else has a design, someone else has a concept or an idea, they bring it to the job shop makes it for them and gets paid. If they get paid, it's clearly manufacturing by my definition, right? Sometimes they say, we're gonna make 10,000 a month of these. Can you make us a few for testing? And a lot of times the job shop will make them a few, and maybe they'll charge them, maybe they won't. It really depends on the relationship that they have. I don't know, is that making or manufacturing? Doesn't really matter. The real thing, the key thing is, in manufacturing we have a customer. We want to do that. So how long have we been manufacturing? When do you think manufacturing started? I'd guess it started, the classroom that I taught in last term had 2 projectors so you could see both things. Back PC. I would guess that manufacturing started back when people started trading things for other things. We have evidence of human civilization, people making tools back, I don't know, 2 million years ago or so. This is the beginning of manufacturing. Anybody know what this one is? Okay. It is not a steam engine, but she's close. Same time frame as the first commercial steam engines. Anybody else got a guess? It is, well, this is just a model. It's sort of like Camelot. But this is a model of the first boring machine. Wilkinson's boring machine. And Wilkinson and Watt were business partners. Wilkinson made the machine tools that enabled Watt to make his steam engines and started the Industrial Revolution. So between here and here, manufacturing was a craft. Really, it was the Industrial Revolution that made manufacturing start becoming a science like we have today. All right, what's this one? Anybody know? Anybody know? Somebody said it. Say it louder. It's not. It's on the way there. That's the Dragon space module. The reason I have a pic, or maybe the Dragon's in the frame somewhere. Pretty sure that's the Dragon. That was, I stole it off their website. The photo credit said that it was. The reason I have this one up here is because one of my students was the chief propulsion system engineer on that. One of my former students, not while he was a student here. And so we've taken, or we're taking now, manufacturing from art, from craft, over here to science. And is science better? It helps us be more repeatable. What's that? I don't know. If you stack it high enough, we'll make it. All right, it won't be a space elevator, but it'll be a space staircase. Okay. I would argue that that manufacturing is actually the oldest profession, and it is the reason that our civilization exists. Without manufacturing, we wouldn't be alive, and we wouldn't have the things we have. Okay. We said, what time is it? 10 minutes. I'm deciding what to do next. 16 minutes? Who must be on the east coast of the campus? Right? Yeah, this is the east side of the campus. That's why the clock's faster. Because Professor Brown's going to give his lectures. He's going to give his quizzes. He's going to talk about this stuff later. All right, just very quickly. Who determines value in the transaction where the manufacturer makes it a product, it gives it to the customer? Customer gives the manufacturer money. First, we could agree that the money that the customer gives the manufacturer, that could be a measure of value. Okay, so who determines the value?
The customer.
What's your name?
Camden.
Camden, sort of the fancy version of Cam. I couldn't resist. Camden says that the customer determines the value in the transaction where the manufacturer makes something, gives it to the customer gives the manufacturer money. Anybody want to argue with Camden? All right, you guys can arm wrestle right here. Matt, what do you think?
I think it's an agreement between both. The manufacturer will make it. They just prefer the price.
Matt is more socially oriented than Camden, and he thinks that it's an agreement. He's more of a Democrat, I suppose. Not necessarily more social, but a Democrat. He says it's a agreement between the manufacturer and the customer. And I would say an agreement has to exist. But anybody else want to argue? Yeah.
Well, I think like in the broader sense, what he says, like the market affects the agreement between the customer and
The market does tend to affect the ability of the manufacturer to get an agreement with the customer for the value. So if the manufacturer didn't agree, the manufacturer says this has more value to me, then they're not going to sell it to you, correct? But it is actually the customer that determines the value at that point in the transaction. Yeah, you had something?
Something's only worth
Everything is only worth as much as someone will pay for it. Nothing is actually worth more than anybody will pay for it. Anybody follow like real estate and bubbles and stuff like that? Yeah. So when the real estate bubble breaks and the housing prices fall, the value of the house evaporates immediately because it only has that value if you're selling it and somebody wants to pay that price for it. Now, if you own a house, you can claim any value you want, but it only actually has that value when somebody's handing you money and you're handing them the house, handing them the keys. You usually don't hand the whole house over. All right, so value is determined by the customer. Oh, what's the value of this guy? Before I was married, I used to do this with real money. Right, it's worth nothing unless someone agrees to accept it in exchange for something. Right, now it does say somewhere on here, good for all debts, public and private. right? But what back? So could you go turn this in at Fort Knox for a piece of gold? Nope, not since 1971. Can't go turn this in for a piece of gold. It's worth what people believe it's worth, just like Bitcoin. Now, this might be worth more than Bitcoin. I don't know, because it does have the 82nd Airborne behind it. Right? We can go enforce its worth if we want to, and the whole Navy. Navies, right? There's fleets. Are there navies or fleets? Just fleets, one navy? Unless we get the NATO guys involved, and then there's navies. Okay. All right. But what's cost? Right? Because if the manufacturer sells it to him for less than the cost, this is problematic, right? So what's cost in manufacturing? What's the cost to manufacture a $100 bill? Anybody know? It includes the materials, yeah. Anybody know how much it costs to make a $100 bill? No, it costs like 7 cents. If the old bills, then they get the funky colors here. The new bills came out. They cost about 12 cents to make. That's a markup, huh? We're in the wrong business. All right. So, but what goes into the cost of manufacturing? Just quickly. Yeah. Materials, raw materials. Yeah. Labor. Yeah. The machines that you use to make the stuff. Yeah. The electricity that runs the machines and keeps the lights on. The time itself isn't a cost, but the labor and the electricity and the machine are all functions of time. So we'll get to time when we get to the first derivative of cost. Transportation, moving stuff around. The place where you put the machine that you supplied the power to. The thinking about what you might want to make. And man, that is probably the most expensive part if you think too long. What else? Anything else? Anything else jump out at you as a cost of manufacturing? So there's licensing fees and insurance fees and taxes and all those kind of things that go into all businesses. But manufacturing is a business. Business has to have a place to operate. It has to have the tools to do the operations. So those costs all go into those things. The difference between value and cost is profit. That makes sense? The first derivative of profit with respect to time is the profit rate. It's the speed at which our company makes a profit. If the profit rate is negative, the company fails. You guys don't want to go work at companies that fail, do you? I've been there. It's not actually that much fun. So if we want to work at companies that are going to succeed as manufacturing engineers, let's think about making sure that we keep a positive profit rate. Okay, we're not going to go into this now. I got one more thing I want to talk about. How much time I got? 9 minutes. Okay. Perfect. Back to this thing because I can't see, you guys can't all see the whiteboard, blackboard. Back. Document camera. Okay. Anybody say on their form that they wanted to, that their reason for being here was to learn how to use the machine tools to make stuff? Anybody? Anybody want to make stuff in this? Anybody, or even if you didn't write it on the paper, does anybody have a significant desire to learn how to make stuff using the equipment that we have here? Usually when I do this is most of the class, one of their primary reasons for taking this class, for fulfilling their requirements with this class, is because they want to learn how to use the machines to make something. Because they got some idea, something that they might want to make someday. In fact, I took this class in 1994. And when I took the class, I was really excited because I was going to learn how to use the Etch-a-Sketch machine and the Etch-a-Sketch lathe. We had both of them. And then I was going to be able to come back to the lab. I was going to be able to make stuff when I was done because I had all kinds of ideas. I mean, most of us came to WPI because we have lots of ideas, I'm guessing. So I had lots of ideas. I wanted to make stuff. So when I finished the class in 1994, don't tell the department head, I got a C. the C was totally a gift because they didn't want to see me take the class again, I'm pretty sure. And I needed to graduate. But I didn't feel like I could come back into the lab and make stuff. I didn't feel enabled. I didn't feel like I could do it. And I didn't actually feel like I was welcome to do it. And maybe it's because I wasn't one of the A students that I wasn't welcomed. But it just, when I took over teaching the class in 2006, I wanted to fix both of those things. If I did nothing else in my tenure at WPI, I wanted everybody to feel able to use the facility to make stuff and feel welcome to come in and do that. So if at any point you ever feel unwelcomed, please let me know. If you ever feel unable, go learn how to do it, damn it. Now, we got a lot of tools. We got a lot of people that help out with this. But what does it take? All right, so making or manufacturing doesn't matter. What does it take to have our thing realized? What do we have to have first if we want to realize something, if we want to make something? Yeah. We do need a plan. It's not first. First thing we need is the idea. We need to have an idea or concept, a thought. If we don't know what we want, we can't possibly make it. Right? It's the most important thing. We have to think about what it is we want to make. Is that enough? Stack of cards. I made it. That started with a thought, right? I thought about wanting a stack of cards, and then I arranged a process via a plan to have a stack of cards appear here, right? I manufactured that stack of cards. Cool. Oh, nobody's going to pay me for them. I made the stack of cards. Okay, we got to have this idea. Now, if we're going to use, and since in this class we're going to use a lot of CNC machines, we're going to use CNC machining processes to make our stuff. We do that, one, because it's a fundamental process. It really is what allows society to function today. Maybe in 20, 30 years, we'll be going up to our replicator and asking for our Earl Grey tea hot. But in the meantime, until we've really developed that 3D printing technology, we're going to be using computer-controlled machine tools and removing material in order to make our parts. If we're going to do this, we have to have an idea. Then we have to turn it into a plan. And the first step in turning it into a plan is we need to have a design. So we can't have a design unless we have the idea first, right? You had 1310? I forgot your name. Next to Matt. Chris. You took 1310? Anybody else take 1310? How many, like last term? Yeah, last term? Recently? Good. So you'll be the design experts now, right? Because they taught you everything you needed to know? Oh, sure they did. But they taught you how to use the CAD software to draw stuff, right? All right, well, that's part of it. So our design is going to be made up of drawings, solid models, specifications, lists of things that we need. We have to have a design. And in the design, one of the primary things that design tells us is what's the shape that we're making, right? So our shape is here. Now, if we've decided to use a material removal process, so a machining process to make the part, before we can move on beyond this step, we must know the shape of the material that we will make the part out of. You can't actually move beyond this step without knowing we'll call it the stock material, or the workpiece. Now, once we know the shape of the part we want, what the stock material looks like, now we can start thinking about how could I apply manufacturing processes to turn the stock material into the shape that I want. There was the art student, and he was trying to do a sculpture, and he wanted to carve a statue of an elephant out of a block of rock. And he goes to his teacher. He says, "How do I carve an elephant out of this piece of stone?" And the teacher says, "Well, chip away everything that doesn't look like elephant." Right? And that's exactly how our CNC machining processes work. They remove away, actually by making chips, they cut away all the material that doesn't look like the part that we want. So we've got to do that. Now, before we start chipping away at it, right, we have to have some understanding of how the processes work and what they can do. So in the class, we're going to use 3-axis milling machines and 2-axis turning centers, also called lathes. In the milling machine, the tool rotates. There's a relative motion between the tool and the workpiece, and it makes prismatically shaped parts. So if we're going to remove, if this is the workpiece, we want to remove material off the top face of the workpiece, we'll do a facing operation that removes material off the top of the workpiece. That uses the bottom of the cutting tool, top of the workpiece as a facing operation. If we want to make a hole, say we want to make a rectangular shaped hole in our workpiece here. If we want to do that, we'll make a pocket in the part with a pocketing operation. Facing operation works on the top of the workpiece, works on the face. In fact, in the lathe and in the mill, the z-axis, the motion of the z-axis, always lines up with the rotation of the spindle. So in the mill, the z-axis moves up and down. It's pretty intuitive because we're used to our Cartesian coordinate system with our right-handed rule where z moves up and down, x moves this way, and y moves this way. That's the way the mills work. In the lathe, you flip it on its side, you put the workpiece in the spindle, so now the tool doesn't rotate, but the workpiece rotates. And the tool moves, in our case, in the x direction only, although you could have a lathe where the tool moved in the y direction, and it makes axisymmetric parts. It makes a part that could be rotated. So when you have your shape here, your idea, you've got your stock material. If you're making a roundy round part, you will probably use a turning operation. If you're making a prismatic part, you will probably use a milling operation. So you decide what kind of operations are you going to cut. Then you have to decide what orientation are you going to hold the workpiece. Then you can decide what tools can make the operations to do this. Then you can get started using the CAM software. So we just did like 5 steps before we got to the CAM software from our idea, right? Now, who already knows how to use CAM software? Raise your hands, be proud. He's a little bit proud. Which one? Use Fusion 360, yeah. We have Fusion available in the labs. In the class, we're going to use Esprit. All CAM software does the same thing. They make the code that runs on the machine tool, and there are tools that help you tell them what you want that code to look like. So after we get our CAM software, after we get into our CAM software, we've chosen our tools, we have to have the process variables that tell the tools how fast to move. Would you believe that if you feed the tool too fast, sideways through the workpiece material, the tool breaks in half? Would you believe that if you feed the tool too slowly through the workpiece material, you risk the tool breaking in half? If you feed too slowly, it actually burnishes the material. It doesn't make a chip. It'll actually build up energy. It'll spring the tool back. And either it springs forward because it finally got enough force, or it breaks. Depends how big the tool is. So those things. So you're going to have to, so you will go all the way through this to setting up the machine, putting the workpiece in the machine, making the part, and have your finished part. You'll get to do that all in this class. Labs. Let me just show you the thing that you're going to make here. And I got to turn the PC back on, I know. There. And so in lab, you'll make one of these thermoacoustic engines. There's a piston in there that's vibrating back and forth at about 1,000 hertz, maybe 1,500 hertz. It does that by building a standing wave pattern inside here. If you make all the parts the right size, it will run like that on the heat of a candle. It's an external combustion engine. Actually, Ben & Jerry's uses the same thermodynamic principles to operate their chillers and their freezers in their manufacturing facility, except they don't light a candle. They push the piston back and forth, and cold comes out the other end. So it's a reversible process. Pretty cool. Anybody have questions for me? Yes? Anybody in the class know the answer to the question? Lab starts next week. So if you have if you're in section 1, labs on Monday. If you're section 2, 3, or 4, labs on Tuesday. There will be a lab homework due on Sunday at midnight, 11:59 p.m., not at midnight. And there will be preparatory material that you need to go through before the lab that you need to turn in by Sunday at midnight. And that'll be posted on Canvas. Canvas will be turned on later today. Yeah. Let me just go ahead and turn this off.
Thank you.